You spin up an AI agent to fix one bug in a big code base, and for the first 10 minutes, it's brilliant. It reads the right files, asks the right questions, answers fast. Leave it running a few hours, and something changes. It starts rereading a file it already opened an hour ago, repeating itself, contradicting something. It said 40 exchanges back. Every answer takes longer to come back than the one before it. Nothing about the model changed. It's exactly as smart as it was at minute 10. What changed is something you never see on screen. Nobody's been minding its context. Everything that agent knows in a given moment lives in one place, its context window, the instructions it was given, the tools it's allowed to use, every message back and forth, every file it opened, every search it ran, all sitting in that same window, all competing for the same space. Even a context window that can hold a million tokens sounds bottomless until you watch one fill up. Read a few dozen files, run a few dozen searches, and that bottomless window is most of the way full before lunch. And running out of room outright isn't even the real cost. Every token in that window gets reread in full. On every turn, the fuller it gets, the slower each answer, the more each one costs. Long before the agent hits the wall, it starts quietly losing track of an instruction from an hour ago, missing what it should have caught. Engineers have a name for that decay: context rot. A full window isn't a problem for later, it's one you can already feel. So, the first fix isn't carrying less, it's not paying for the same thing twice. Every turn, the agent resends its instructions and its tools, everything unchanged since the last message, and normally pays full price for all of it every time. This is what prompt caching fixes. It lets the agent reuse that unchanged part instead of rebuying it, as long as it's byte for byte identical to what it sent last time. Byte for byte is the catch. Change one character anywhere in that shared part, and everything after it loses its discount on this request and everyone after it. Which is why the stuff that never changes has to come first, and the stuff that changes every turn has to come last, or you're paying full price without ever noticing why. Caching keeps the bill down, but it doesn't shrink the window. Eventually, the window itself is the problem, and that's when engineers reach for one of two fixes people mix up constantly. One is deletion. Once a search result from 3 hours ago has done its job, just cut it out of the window entirely. That's context editing, pure subtraction, nothing rewritten, it just leaves. The other is compression. Fold the oldest stretch of the conversation into a short summary and keep going. That's compaction. Distillation instead of deletion. Mix the two up and you reach for the wrong one at the wrong moment, editing away details still worth keeping or compacting junk that should have just been deleted. But say the agent finishes for the day and the whole session closes every convention it learned about your codebase. Every decision the two of you made is gone. The second that window disappears, nothing so far survives past one single conversation. So there's a separate piece entirely for that. A persistent memory the agent can write to and read back from days later in a brand new session, starting from a completely empty window. Not a bigger window, not a smarter summary, a place outside the conversation that's still there when the conversation isn't. Now, say the bug isn't in one file, it's somewhere in 40,000 lines, nobody's mapped in years. Grinding through that search turn by turn would drag the main agent's own context through every dead end along the way. So instead, hand the whole search off to a separate helper. Engineers call it a sub agent, running in its own context window, built to do exactly that and nothing else. It does the messy work, follows the false leads, and reports back exactly one thing. Here's the file, here's the line. The main agent's context never saw any of the mess, it just got the answer. Sub-agents solved the search problem, but a single tool call can be the whole problem by itself. Ask it to check the logs, and if the tool hands back every line from an entire day, the agent's context window is now mostly log spam from one call. The fix isn't to stop asking, it's making sure the raw answer never lands in the conversation at all. Write the log file to disk and let the agent read only what it needs, or better, have it write a script that filters those logs down to the 10 lines that matter. Same information available. A fraction of it ever has to sit in the window. Which raises the bigger question underneath all of this: why load any of it into the window at all if you could fetch it exactly when you need it? That's the other camp entirely. Retrieval or AG for short, search for the one relevant paragraph the moment you need it and hand over nothing else. It's leaner and cheaper, but it trades away something too. A retrieval step can miss the paragraph you actually needed, where a model holding the whole document never had to guess. Nobody's declared a winner here, and nobody should. It's a real trade off between precision and completeness, and the right answer changes with the job. None of this is theoretical for people building at scale. A coding agent chewing through a real production code base for a full workday will blow through a naive context strategy before the coffee is even cold. A support agent that's supposed to remember a customer's whole history isn't worth much if it forgets who they are the moment the window closes. Get this wrong at that scale, and you don't get a slightly worse answer. You get a bill nobody signed off on, and an agent that quietly stopped being useful hours ago. And here's the part worth saying honestly. For plenty of jobs, none of this belongs anywhere near the conversation. Classify one email, pull one number out of one document, answer one question once, and be done. A task that starts and finishes in a single turn was never going to fill a window or need a memory that outlives it. Building all of this for a one shot task doesn't make it more reliable, it just makes it slower to ship for a problem you never had. Go back to that agent at minute 10, still sharp, still fast, still exactly as smart as it will ever be. The version still that sharp 200 turns later isn't running a better model. It's running the same one with a context window somebody actually took care of. That's the whole difference between an agent that ages like that and one that's already forgotten what you told it 4 turns ago, not intelligence, just what it was allowed to carry.